In the previous video, we were discussing Kirchhoff loop rule. Here we saw four examples and two ways of how doing it. We saw that we can pick the direction, arbitrarily the direction of the current, and that we can also define how we want to be the drop of the voltage, the dropping. If going from positive to negative, we said that this is a positive drop, so we will put, for example, if we begin in this point and we take all this loop around, we said that the integral of E dot dl, that this is the voltage all around, this would be minus V1 in this case. Actually, I will just take this part to do it simple, the point that, to illustrate simple the point we want to show. So just like this, a simple circuit with just one resistance. And here we have minus V1, and here we have a drop because we are passing through the resistor, so minus I1 R1. And we will find the current, we have the resistance, and we have the voltage, so we will find it. In this case, this is equal to 0 because we don't have any inductance, and we are talking about Kirchhoff's loop rule. So here we just have that V is equal to I1 R1. There is also another way to do it, that is thinking more about the direction of the electric field. So the direction of the electric field in this case is always from positive to negative. So this is the direction of the electric field. In the resistor, the direction is from positive to negative, but could be so the current. Now we will assume the current is going in this direction because it's from positive to negative. So the electric field in the resistor goes in this direction. So there is other way in which we could say 0 is equal to this electric field times dl. So it would be whatever you would be positive, so would be V1 positive because we're going from positive to negative, and here we would say we're going in the other direction because we took this direction for the loop, for walking around the loop. The L is in this direction, and the current is going in this direction. And the electric field is in the opposite direction, so we would say negative I1 R1. And so here we would have V1 is equal to I1 R1, and we will solve for I1. Actually here, it is, if we send this to the other side, we have V1 equal to negative I1 R1. And that means that the direction of the current was in the exactly opposite direction that we took. In this example, as we did in the four examples that we had in the previous video, we said let's think that the current goes in this direction, and actually here we're saying that it goes in the other direction, and that is because the electric field goes from positive to negative, so the direction of the current is in this direction. So we could use this way and just note that if we have a negative sign, it just means that the current goes in the opposite direction, or we can use it in the more intuitive way, in the sense that from the beginning we are making sure that we know exactly the direction of the current, knowing the electric field if it's going from positive to negative, and like that we will assign the direction of the current from the beginning in the nice way. But I think that both of the ways are very simple. This one we will use it more when we talk about the capacitors and the inductors.